Okay, guys. Today on this, we're going to talk about. Today we're going to talk about heads and installing the heads onto the engine. This is the head of the engine. The head consists of a few different parts. It consists of your valves, which open and close and let the air and exhaust into your engine. It consists of valve springs, keepers, guides, valve retainers, which keep the springs on. It consists of rocker arms, and it consists of your intake port and your exhaust. All of these parts in the top end. The top end is where you make the power. The bottom end is where you build longevity. So the top end is, this is how the head flows. This is how all of your power is made through your head. There's an actual equation that depicts how much air your head can flow, how much possible horsepower you have to make. Without even dynoing an engine, based on your CFM of flow through your head, there's an equation that could tell you how much horsepower your engine has for potential. It's pretty close. It's not always exact. There's a couple other things that affect it, like your wet flow, how you cylinder fill. But a lot of the flow tests they do these days, they can judge your velocity, swirl, stuff like that. I know the flow test I work on or work with judges all of that stuff. So at this point in time, you've got your lower engine built. Once the lower engine's built, you're ready to pretty much do your head installation. Now, before installing your head, make sure everything is clean as always. Make sure all your port-in's done. Make sure your valve seats and valve angles are cut and blended, which is down in this area. You want to make sure there's multiple angles that get cut on valve seats, and the more angles they cut on the seat, the better the air can turn and flow into the head, filling the cylinder. So you want to make sure at this point in time, if you're going to be cutting your valve seats, that the angles are cut and everything is blended at this time, that all your intake porting has been done, that your valve guides have been installed. The valve guides are what the valves slide into down here. You want to make sure that those are installed. You want to install those before cutting your valve seats, because installing a valve guide will definitely change how your valve sits on the seat. It could change it left to right or top to bottom, and the seat won't sit concentrically with the valve. You'll have to recut the seat to get the valve to sit perfectly straight with that guide. So make sure all of your seats are cut, your guides are installed if you're going to install new guides. If you're dealing with the new head, that's fine. A lot of the times on the valve guides, I like to install like these guides. These are bronze. There's a few different things about bronze valve guides that are better. Well, first of all, they have more of the same heat characteristics as aluminum does, which means they expand pretty much the same, unlike other types of guides. And also, bronze is self-lubricating in some ways. Once you install the guides, what you want to do is clearance them to your valves. You want to measure your valve with the micrometer. Find out the width of your valve, and then cut the guide to have the proper clearance between the valve and the guide. With bronze seats and stainless steel valves, on my intake I run 1.2 thousandths, and on my exhaust I run 1.5 thousandths clearance. That's a very tight tolerance. The reason I do that is because the more space there is between the valve and the guide, the more this valve can rock around. Some people just like to run them really loose. That way they're not going to get any customers coming back saying, oh, well, I stuck a valve or something like that. But having that loose is really going to throw the valve off. When it comes to close, you want it to be straight sealing on that seat every time. There's only talking about split second for that valve to seat, and if it even rocks the slightest bit, You know, heads are made in the guides. The guide is the #1 point of the head. You have to have your guide straight and true. That's the starting point for every head. So once you have all of that stuff taken care of, you've had your head flow tested if you're going to flow test it, you know your numbers. The next thing you want to know before installing your head is your compression ratio. In order to know your compression ratio, there's a few programs out there that will help you calculate your compression ratio. There's some factors involved with it. Basically, if there's any cutouts in your pistons, like say these valve reliefs, these have a volumetric area to them. So there's a few things that are involved with it. Basically, the CC of your head. So you can find out the CC of your head by CC testing your head. You could take a piece of plexiglass with a hole in it and bolt it onto your head. If there's a little hole right here, and you could use a syringe and pump water into this and calculate the CC of your head. You want to make sure you put a little bit of grease underneath your valve seats to make them waterproof, and make sure you put a spark plug in it. I've done a video before. If you want to find out how to CC a head, you can look through my videos on my page and you will see the video on how to CC a head. Also, I show how to CC a head gasket. Knowing all of your volumes will help you calculate your compression ratio. Knowing your compression ratio is vital to building an efficient, well-built engine. So once you know your compression ratio and you know the CCs of your head gasket, you know the volume. If you put in an aftermarket piston, most piston manufacturers will put a card or label on the box how much area the valve reliefs in the head are. If not, you can do the same thing by bringing the piston to top dead center, put in a piece of plexiglass on the engine, drilling a little hole in the plexiglass and putting water in it and finding out the volume of the bottom half of the engine. Once you know your all the CCs, you can take that amount. So I know this is 22 CCs in my head, and I know I'm running a 10,000 thick head gasket, and my piston is at 0 dec, and I have 4 cc's of volume in my piston. When I take all that and calculate that against the fact that I have a 460 cc cubic inch engine, it comes out to around 15:1 compression ratio, and knowing that is vital to running the correct fuel. If you go ahead and mill your head, say 100 thousandths, put that on and run regular fuel, you could get detonation and blow your engine. So knowing your compression ratio is vital to building an efficient engine. So after that, you want to know, before installing the head, you need to know about the cam you installed. Now the cam has amount of lift on it. Now the amount of lift the cam has tells how much it's going to lift this valve. The more lift, the more it lifts the valve. The more it lifts the valve, the closer it comes to the piston. So you need to know how much valve lift that your cam has. And also, if you're using a ratio rocker, like these gauge roller rockers that I'm using, you want to make sure you calculate the ratio rockers into the total lift. If you have a 400 lift cam and you have a 1.1:1 ratio rocker, a 1.1 ratio rocker will add 10% to your overall lift. So if it's a 400 lift cam, 10% of 400 is 40, so you're going to have 440 total lift. If like these, you have a 1.3:1 ratio rocker, these are going to add 30%. So if you have a 400 lift cam, 30% is 120. You're going to have 520 total lift. So knowing your total lift before you move forward, installing your head will definitely help you from running into problems with piston to valve clearance. Piston to valve clearance can be obtained through not milling the head, or it's just the space between the valves and the pistons. You need a minimum of 80 thousandths piston to valve clearance. Anything closer than 80 thousandths piston to valve clearance, you can run the chance of the valve hitting the piston. Now that necessarily won't happen if you just float a valve, but if these engines get hot enough and are run hard enough and turned hard enough with aluminum rods and aluminum piston, aluminum tends to stretch. When aluminum stretches, the piston can actually come further, even the piston can rock and it can hit a valve. You want to make sure you have the correct piston to valve clearance. I'll show you how using something. This is a cheap, inexpensive, just a digital readout. I'll show you how to check your piston to valve clearance later on in this video. So when you have a lot of lift on your cams, you want to make sure that your valves are long enough. I've talked about this before in other videos. When you have your retainer on your valve, you want to make sure you don't come into any type of one, coil bind, and two, you don't want your retainer to hit your valve guide seal. If there's any type of contact in there, there should be a minimum of 60 thousandths between your coils when fully on the nose of the cam, and there should be a minimum of 100 thousandths between your guide and your retainer. Just so you guys know, you're probably looking at these valve seals in here. These are a Kibble White valve seal. I purchased these online through Kibble White. This is the part number. They're the red seals, red Viton pack of 4. I got them through Kibble White. Actually, there's the part number. 191-36013. On the gx390 head stock, they don't come with an exhaust seal because the material they use on the stock heads is just cheaper material. So these Viton seals are extremely strong and made for racecraft engines, so they will last. The more you can seal the valves up, the less oil you're going to burn, the less compression you're going to lose, the more bang you're going to have for the buck. So next, what we can talk about, so while installing your valve head, you need to check for piston to valve clearance. The way you can do that is using clay. You can use clay and pack clay into the engine, bolt your head on, rotate the engine around, and as the engine's rotating around, your valves are going to open and close. Rotate the engine around twice, pull the head off, check your clay, take a razor blade and cut the clay here. After you cut the clay, you can use a digital caliper to check the thickness of the clay. I've also done videos on how to check your piston to valve clearance. If you need to, you can check on my page for that. So something else that's important on installing a head is installing your valve springs at the correct install height. Now every valve, every cam rather, has its own needs. The cam might need more spring, it might need less spring. The more lift compound with the more ratio of the rocker, the valve is going to need stronger spring to support the cam, to support the valve stability. The higher the lift, the heavier the valves, the bigger the valves you put in, whatever the case, the higher the RPM. All of these things lead into pushing your spring further and further past what it was designed to do. Through a lot of my trial and errors building these engines, I found that they don't really make the correct spring. I actually had to go through Manly and get some springs ordered through them. These are actually made through a car manufacturer. So these springs here can handle my lift and can handle up to 11,000 RPMs. They're made of a they're made of a silicon chrome, which has been, all kinds of treatments done to it, shot painting, heat treatment, stuff like that, and it's been tested up to 11,000 RPM. So you want to know your spring install height before installing your head. When you take your guide and put it on the spring, the area that this guide sits down at when the spring is installed is your installed height. So you need to get in here with a caliper and measure from the floor of the head to the bottom of the retainer and find out when this retainer is correctly installed, and you need to measure that. That's your install height. Now your install height has to match the install height on the spring. Most times, if you just go out and get a regular valve through Bullfrog or NR Racing and you get the regular cam, if you're doing under say 400 lift, you don't really have to worry about any of that. Say under 375 lift even. Most of that stuff, they've already done all the legwork that you can just bolt the stuff on. You don't really have to worry about it. When you start getting up above 400 lift, 375 lift even, that's when you really start after worrying about clearances and the springs being able to handle the RPM and the stresses of the high lift cams. So once you find out your install height, you want to make sure that matches your springs install height. I know if you go out and you buy the NR Racing valve spring, it wants an install height of 1/200, and when I measure from the floor of my head to the bottom of my retainer, I'm at 1.350. So at 1.350, that NR Racing spring would not have enough seat pressure to hold that valve closed. That means I would have valve bounce, etc. So make sure your springs are matched to your cam. A lot of the time, the cam, just like the piston will tell you the volume of that, the cam will tell you what springs it needs. Another thing to remember, they're thinking that you're going to use the cam without a ratio rocker. So if the cam says it needs this type of spring and then you're putting a 1:3 ratio rocker on it, or a 1:5 ratio rocker, or 1:2 or 1:1, just know that you're now going to be pushing that cam and that spring above what they're listing it to handle. So you want to know the pressure of the spring as the seat pressure as the valve's closed. You want to know, and then there's on the nose pressure or open pressure. Like the NR Racing springs that you guys are probably common with has like it has a seat pressure of 65 pounds and an on the nose pressure of 140 pounds, and that's at 375 lift. These springs here have a seat pressure of, at this install height, 80 or 72 pounds of seat pressure and 170 pounds on the nose open pressure, and I need that to run the cam that I currently have at this lift. So once that's all set and you have your springs installed and all your geometry, or you've checked all your make sure nothing's going to hit, like, your retainer to guide or your coil bind, and that's all fine at your lift. You just want to make sure that your rockers that you're running are really good rockers, especially if you're running a ratio rocker and you're running high valve lifts. If you've seen pictures of a stamp steel rocker at 8,000 RPMs with a heavy valve spring under it, that thing is kind of like, it's dancing a little bit. What I have and what I use on the high lift are these gauge roller rockers. They're a shaft mounted roller rocker. I've used them in a few builds now, and I'm very happy with them. I've never had a failure. The only time I've ever had actually a valve failure was, it was my own fault. I had coil bind and I had a rocker stud pop off, and luckily that was all that happened in that situation. That was a long time ago, but that's an example of something that happens if you have coil bind. If you pop a rocker stud, 9 times out of 10, that's what you have, coil bind. So you want to have correct rocker arm geometry. You basically just want the rockers, when they're sitting on top of the valve springs, to be slightly angled back. There's no real technical exact angle that they need to be sitting at, and I mean, I've installed them basically just eyeball forever. As long as they're slightly angled back, they're perfect. You are going to need, most of the time, a cut to length push rod set, chromoly push rods. I got these ones from NR Racing. They've worked so far for me. When you are putting the little ball ends in, make sure you don't just hit it on some cement with a hammer. Take one of your lifters, put it on the ground, put the little ball into the top of the lifter, and then, on like an extra set of lifters, and use the lifters, because the lifter will fit this ball better and will help to apply the pressure evenly while you're pushing in the ball end. But these rocker studs, these push rods are 7" and they're cut to length. I don't know exactly what length I have them at now, but I just figured out what I needed and cut them. You're gonna probably need cut to length push rods, especially if you're running gauge roller rockers. Another thing, make sure you run lash caps. Running lash caps on the valves, a lot of people I see, they don't run lash caps. I don't know why. I mean, for one, if you run that engine for say a year or two and you try to take your valves out, you're gonna have a big mess. Those valve stems, I don't care if they're hardened or not, they're gonna be mushroomed. You're not gonna be able to pull the valves through the guides. You might even end up having to sand or remove some of the guide valve material just to be able to get the valve out. Also, when you run a lash cap on your valve, you actually make the valve seem a little bit longer to the rocker. So if you are kind of having a problem where maybe your rocker is hitting your retainer, if the rocker might be hitting the retainer as it's pushing on it, sometimes just adding a lash cap is enough to move it up out of the way. And another thing with running lash caps, I have a few different kinds of lash caps here. These are all for 6.5 millimeter valve stems. Some Honda and some just, I think, NR Racing ones. You know, they're different thicknesses, they're different widths. You want to make sure that the rotator is not, the lash cap is not pushing down on the retainers themselves, on the keepers, because you don't want the keepers to get pushed out through the lash cap. Make sure the lash cap is solely sitting on the valve. And another thing with lash caps is it gives a bigger footprint. If you look at these valves here, they're 6.5 millimeters. If I take, say, one of these lash caps and put it on the end of the valve, you'll see that the valve is now a lot bigger. You see how big that appears? Now that's just a whole lot of extra room to be running your rocker on, especially if you're running inexpensive rocker arms that move around and stuff like that. You know, I run them even with the gauge roller rockers. It just gives you more footprint for the rocker to be pushing on the valve, and it does not damage the valves. So make sure all these things are taken care of before you even attempt to install the head. It sounds like a lot, but it's really not that much. These are all things that you have to do. I don't want to make it sound like it's overwhelming. These are just, to most people, these things are fun. These are things that you have to do when you're racing or pushing for a performance level. Most people that are just doing this for like a lawnmower repair or water pump or something like that, they're not worried about the true performance. You could just throw stock guides and stock retainers, even if they're worn out. Just put some fresh springs and, you know, you're probably good to go. Just lap your valves and it'll probably be fine. But this is stuff, you know, if you're just really changing the internals of it, the cams, the ratio rockers, high lift, these are things that are absolutely necessities once you're doing that. But that's the thing. Those are the things that you have to take care of before you install the head, and make sure that you check. And after this, I'll show you how to install the head.